Okay, now let's have a look at now velocity time graphs. And in my previous video, I just looked at displacement time graphs. So check that out if you already haven't. Now with velocity time graphs, it's a very similar concept where we read velocities or times directly from the graph. We use the gradient to find the acceleration of the object, and we use the area under the graph to find the change of displacement of the object or the total distance traveled. Now let's have a look at a question here that you may have been familiar in class with. So if we're looking at the graph, you can see that it's going at a constant uniform velocity. So to answer the questions, it should be pretty straightforward. So let's have a look. There is a set of questions in that table, and I'm going to display the answers in a minute. So finding the initial velocity of the car is very simple, and it's just what you see at the beginning, which is just 0, okay? And finding the final velocity is just 20 meters per second south. Okay, so that's pretty easy. Now to find the velocity of the car at 7 seconds, we're just going to read directly from the graph again. So you should get 14 meters per second south, which is again straightforward. Now, when was the car moving at 15 meters per second? And I'm going to say now this is by interpretation 7.5 seconds. Okay, so what was the acceleration of the graph? Now this is where we use rise over run, the gradient. So basically 20 divided by 10, which is just 2 meters per second south. Okay. Now F, find the change of displacement of the car. Now to find displacement, it's just the area. So it's just 20 times 10 divided by 2, which is 100 meters south. That's the area below that solid line. Now what was the total distance traveled? Remember it's scalar, we don't need a direction, so it's just 100 meters. Pretty straightforward. Now, that will help us answer the next set of questions about average speed and average velocity of the car. Now, if you haven't watched my previous videos on average speed and velocity, I suggest you check out the Kinematics playlist on my channel. And if you haven't already subscribed, subscribe. Why not? I've developed that many resources for the new prelim physics course and the old physics course. So let's have a look. Average speed is just distance over time. So you've got 100 divided by 10 seconds, which is just 10 meters per second, straightforward. And average velocity is displacement over time, so you need a direction, so just 10 meters per second south. Continue watching my videos. I'm going to do an acceleration time graph video